Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, we will talk about capacitors and capacitance from Cambridge A2 Physics. In this lesson, we will only focus on past paper question, and today's question is from March 2016, question number 7. Part A is simply asking us to define capacitance, and this question is kind of typical question. You will see this question again and again in many past papers. So now how we can answer this one? So this is quite straightforward one. Simply we need to understand Q is equal to CV, and C is the capacitance, so we can say C is equal to Q over V. Simply we can say charge per unit potential difference. So this is how we can answer. For part B, simply we need to find the total capacitance of capacitors connected in series. As you can see here in this circuit, these capacitors are connected in series, and these capacitors are not identical capacitors, mean their capacitance is different. Simply we need to derive this formula. So how we can derive this formula? We just need to understand one key concept. If we are clear about that concept, then we can derive this formula. And that concept is same charge when capacitors are connected in series. Same charge when capacitors are connected in series. So how they get the same charge? So let me little explain to you. You can see here, this is positive terminal of the battery and this is negative. So the plate with positive terminal of the battery will gain net positive charge, and the plate on the negative side of the battery, means next to negative terminal, will gain net negative charge, and the plate next to negative will get net positive charge, means will be positively charged, because electrons will be repelled from this plate and electron will come to next plate, and these electrons then repel electron from next plate, and this next plate become negative. So this is how these plates are charged, mean the capacitor is charged. So in this case, there is the same amount of charge on each plate, But we need to be quite clear about this one, as Q is equal to CV, as Q is the same on each plate, but C is different. If the C is greater, potential difference will be small, and vice versa. So if big capacitor, potential difference will be lower. If it's a small capacitor, potential difference across that capacitor will be higher. So based on this one, we can derive formula. So this is, I have already derived this one for you. So you can see this is quite neat and clean. So I will explain you the main concept now. So that's all for this part. As you can see here, V is equal to V1 plus V2 plus V3. It simply means that the total EMF of this battery is equal to V1 potential difference across first capacitor plus potential difference across second one plus potential difference across third capacitor. As we understand, Q is equal to CV, so simply V is equal to Q over C, as we have written here, and Q is the same, so simply we can cancel Q, and our final answer is this one. This is what question was asking us to show. So this is our final answer. In the last 4 videos, we have discussed a lot about capacitors in a circuit, and this part C is about capacitors in a circuit. So the most important thing what we need to understand is that it is given to us the switch has 2 positions. As you can see here, A and B switch is here. We can move this switch to A or we can move this to B. Part C1 is asking us when switch is moved to A, we need to find the combined capacitance of two capacitors. These two capacitors only we have in this circuit, and here is a resistor and here is power supply. We simply need to find the total capacitance. So when we move this one, switch means we move from this point to here. So you can see here these two capacitors, they are connected in series now. So we need to find simply total capacitance. I will not talk a lot about this one. I will simply show you the answer and little explain, because we have discussed a lot about this. As you can see here, as capacitors are connected in series, the formula simply we use 1 over C has to be equal to 1 over C1 plus 1 over C2, and this is what I did here, and this is our final answer. So this is 150 microfarads. This is our final answer. 200, 600, simply we solve. This is our final answer. So let's move on to next part now. This is C2. You can see here we need to find the charge on 600 microfarad capacitor now. As we understand, these two capacitors, they are connected in series, so it means they have the same charge. As they're connected in series, it means they have the same charge. So we can simply say this is the key concept. We have to be quite clear about this one. And also you need to understand, as we are talking about this C1, and C1 has again two parts, part 1, part 2. It means still we are considering when switch is moved to A. So this is important point. You have to be clear about this. You need to understand how to read questions. Same charge. So how we can find the total charge on capacitors? Simply we can find the total charge, that will be equal to QC total times EMF of the battery. In this case, the total capacitance we have found. So this is the total capacitance. This is 150 microfarads. We can write down 10 to minus 6 because it is in micros, and we need to multiply by 12 volts, and that will be our final answer. So in this case, if we multiply, our final answer will be 1.8 times 10 to minus 3 coulombs. So this is our final answer. And 1.8 times 10 to minus 3 coulomb charge on 200 microfarads, and also it is the same amount of charge, 1.8 millicoulombs, I can simply say, is on 600 microfarads capacitor. For this part, simply we need to find the potential difference across the 600 microfarad capacitor. We have already found the charge on 600 microfarad capacitors. If you remember from part 2, we have found that the charge on 600 microfarad capacitor is equal to 1.8 times 10 to minus 3 coulombs, and its capacitance is also given to us. C is 600 microfarads. It means 600 times 10 to minus 6 farad. So this is what we need to find. We need to find the V. So we can say V is equal to Q over C, because we understand Q is equal to C. V. We just need to plug in values, and that is our final answer. So this is 1.8 times 10 to minus 3 coulombs divided by 600 times 10 to minus 6 farads. If we solve this one, our final answer is 3.0 volts. Now switch is moved from A to B. As you can see here, switch is moved from A to B. Now this is our circuit, and battery is disconnected. In this case, capacitor will discharge. So simply we can write down capacitor will discharge because there is no battery in the circuit. So what we need to find out, we need to find the potential difference. we need to find the potential difference across 600 microfarad capacitor when it has discharged 50% of its initial energy. So simply we can say its initial energy is equal to E, for example. We can simply say initial energy is equal to E naught. And E naught we can also calculate because we have value of potential difference across 600 microfarad. So we can say energy is equal to 1 half CV square. We can also replace V with its value, and that is equal to 3. So this is the initial energy. Now the final energy is half of initial. We can also say EF is equal to E naught by 2. We can also say that E naught is equal to 2 times of EF. This is our main result, and rest is just we need to plug in numbers. So as you can see here, so this one is the value of E naught. So this is over E naught, and this one is E final, and the C is common on both sides. We can cancel, and if we solve for V, so this will be our final answer. So the value of potential difference is 2.1.